Alright kids, a couple mistakes or things that I want to discuss with you. There's a question in the copper report about some wavelengths of light, and that's something we have not gotten to yet, so if you don't get that question, that's alright, we'll get to it at a later date. I can give you the answer to it if you want it and you want to throw it out in your report, but you don't have to have it in there. Okay, secondly, that problem that we were working on, if we can pull that thing back up. Let's see if we can do that here. We'll go back to it. And there's that mess of the problem. So if you'll remember, it was a 0.487 gram sample. So what happened was I got too quick here on these. But we can still use these numbers to help us. We know that we have if you remember back, we found that we had 0.03. I'm going to put these over here. I'm carrying these over here. So 0.030 moles. I'm not very good writing with this thing. Moles. So I'm going to have to switch over to the actual writing device. Apologize. So when we do this, then I'm probably going to move these down just a little bit because I think that's probably will be the best thing for us. So we'll take the 0.0300 moles of carbon. We had 0.003 moles of nitrogen, and we had after our little faux pas there, we had 0.0361 moles of H. So we need to convert these to grams. We can get the empirical formula from that. We could if that's the only thing that's in the compound, but are we sure that these three things are... We're going to multiply this one by 12, by 14, and by 1.008. So when we do that, here we get 0.036 mole. Here we grams, excuse me. Here we get, get my calculator out here. I have my decimal point wrong on that other one. So it's on this one, the 0.03 times the 12 is 0.36 grams. Sorry about that. And then 0.003 times 14 is 0.042 grams. And then the H is the 0.0361 times 0.008. And we get about 0.036 grams. So that was this answer in there. Okay, now, if we add those three up, we get 14, we get 8, we get 11. Well, we gotta line those up, my bad. That's 0.438. So we go back up to the original beginning of the problem, it's 0.487. So 0.487 minus 0.438 is 0.0, and then here we're going to take that, set 0.049 grams. That must be oxygen. Now, let's convert that to moles. So 0.049 divided by 16 is 0.003 moles of oxygen. So now, let's put it over here, 0.003 moles of oxygen. Let's do these divide by the smallest. We'll divide by 0.003. This is going to be 1, 1. That's going to be 12, and that's going to be 10. So we're going to have C10 H12, N, O. So if you'll look at that, that's really nice. That's going to give you that compound. Then, of course, we can get our molecular mass of this thing, which would be, we'll take that times 12, 120. 12 times 1 is 12. 1 times 14 is 14. 1 times 16 is 16. So we get 12, 3, 4, 5, 12, 3, 4, 5, 6, 162. And they told us that the molar mass was about 324. So 324 over 162 is approximately 2. So the real formula is going to be C20, H24, N2O2. Hope you enjoyed it. Let me know on that other one about the problem about the waves. Don't worry about it. 6 minutes of fun. Goodbye.